around. On number 52, you have to go back to left. I missed it when I assigned it. I calendar from last year when I did these stuff. Tangent, go right to left. You have to go right to left on number 52, otherwise it does not work. You'd be sitting there all day long. Yeah. I promise everything I give you guys is always left to right. I just completely forgot about that one. That was my bad. It works, and I'll show you guys how to do that when we get into this one today. So, with that being said, start off 39, tangent, cotangent over secant squared. So we start tangent, cotangent over secant squared. In this case here, what I would start thinking of, since I've got an addition sign within my numerator, I start thinking of common denominators. I had two. Common denominators. Sine over cosine. Cosine over sine. And just bring this across. Okay. Common denominator then gives you sine squared plus cosine squared. All over cosine sine. Divided by secant squared, if you will. Secant squared is 1 over cosine squared. Bring it up and flip it. What's sine squared plus cosine squared? So this becomes 1. Cosine drops, you get cosine over sine. Just cotangent.
Cosine over sine.
If I'm not mistaken, the next one is the same. What's up? Yeah. It's supposed to call the what? Yes. That's kind of how it goes. Yes, ma'am. Oh, sure. Sorry. This one should take.
Oh, never mind.
Guys, enough. 40 is basically the exact same problem. 41. When you get to 41, you just distribute. You've got a cotangent. In the parentheses is a binomial. There's two terms. It's cosine tangent plus a sine. Distribute all the way across. You still wind up with two terms. You get cotangent, cosine, cotangent. Plus cotangent sine. Cotangent and tangent are reciprocal functions. What happens when you multiply reciprocal functions together?
They get rid of each other.
They get rid of each other, become 1. So you wind up with cosine plus cosine over sine times sine, which is cosine plus cosine, which is cosine. The next one is basically the same, cotangent. You just get a common denominator that goes through.
What do you get as the answer?
For what?
For 42.
Oh. That sounds right, because you have sine in the denominator, you get cosine. Sine squared, cosine squared in the numerator. Yeah, I think it's cosecant. Sounds good. 43. 43 is usually where the wheels start to come off because you don't know what to do. You're like, oh, I was before. Okay. A lot of times at this point, people start thinking, do I try to do reciprocal functions with secant, write it as 1 over cosine, get common denominators, flip things around, and go from there. There's a bunch of different ways you can go about it, but just think, tangent squared. You see a tangent squared, there's a secant somewhere hiding. Maybe try and write tangent squared in terms of secants. Tangent squared is 1 minus secant squared. I'm sorry, secant squared minus 1. So if I rewrite that as secant squared minus 1 over secant plus 1. factorable. Is that a perfect square?
Yeah.
Is that a perfect square? Is that a subtraction? Squares. Good.
Not the way you had it. Not the practice, yeah. I used a lot of space.
Good.
I even used the space between problems.
So what's secant minus 1 plus 1? What's secant?
Wow, that's so simple. Somewhat.
44, it's forcing you to do a common denominator for the numerator. And then you can do the common denominator for the denominator part and get a complex fraction. I'm just going to write that one down right as the standards. So I have 1 over cosine plus 1 over sine over 1 plus sine over cosine. Okay, this is 44. I'm going right to that because I've got reciprocal functions and I've got a tangent. That means that all of them can be rewritten in terms of sines and cosines. It's creating a complex fraction. From here, numerator is pretty easy. You get cosine sine for the denominator, and you have a sine cosine for the numerator. Okay. Denominator, same deal. Common denominators can be a cosine. So you wind up with a cosine plus sine. Question? Complex fraction. Keep. Flip the bottom part. So as you bring this one up, you get excuse me, cosine over cosine plus sine. You will get 1 over sine, which is?
For which one?
I got that answer for that in.
It's logical and I can figure it out. It works. This stuff takes forever to go through. You guys have to use space so I can see what you're doing. Draw arrows in the direction you're going.
I did. You just didn't. Oh, you look at the spacing. I like the arrow direction.
How many turns of homework do you have again? All right. Yeah, just cosecant. 1 over sine. Okay. When I did this one is the more complicated one. This one does take a little bit of space. Not to say that somebody else might have found an easier way to go about it. I looked at it as I saw that I could make this into 2 separate complex fractions, but that just seems like it would be an awful idea. So what I did is I just went for and try to get the common denominator, okay, right off the bat. So when I do the common denominator, I'm going to have a 1 plus secant and a tangent for the common. Fraction on the left needs a tangent. Fraction on the right, I have to FOIL it. When I FOIL it, I get 1 plus 2 secant plus secant squared. Okay? At this point, you'll start to see that those tangents and secants don't mind, but I know that tangent squared can be rewritten in terms of secant squared. Tangent squared is secant squared minus 1. If I do that with that numerator, then I have plus 1 plus 2 secant plus secant squared all over. I'm just going to draw an arrow for the same denominator instead of changing. Now I can combine like terms. Combine like terms in that numerator. 2 secant squared plus 2 secant. Right there. All right. So you have 2 secant squared plus 2 secant over 1 plus secant tangent. GCF. Why, close the lid, please. 2 secant, okay? You get secant plus 1. What goes? Now you're not quite done yet. When we had situations like this before, two different trig functions, the fraction, we split them. Remember that? So I'm just going to write it out with showing the extra steps here so you guys see where this is coming from. Means the same thing. Agreed? Okay. Secant is the reciprocal of what? Cosine. So secant is 1 over cosine. Okay with that? 1 over tangent is cotangent. So this becomes 2 over cosine times cotangent. What's cotangent? Can you get 2 over sine, which is 2 cosecant. Remember, if you have a fraction that can be rewritten, always rewrite it so there's no fraction. It takes a little while to get into that one, but the trick for that one was going back to your identity. Go back to your identity on that one as opposed to.
That's, what was the last?
46 is very, very, very similar to that. Forty-six is very similar to it. So I'm going to go to 47. Cosine plus sine squared plus cosine minus sine quantity squared. Basically, all I can do here is FOIL everything out. Okay. So I have a cosine squared plus 2 cosine sine plus sine squared, bless you, plus cosine squared minus 2 cosine sine plus sine squared. What's 2 cosine sine minus 2 cosine sine? 0. What's cosine plus sine? 1. What's cosine plus sine? .48 is very similar to that as well. Verifies. 1 plus cosine over 1 minus cosine secant plus 1 secant minus 1. Now, this is when you start trying to you're trying to figure out how do you get it to make it look like that. And in this case here, my original thought was, all right, I've got a fraction, I got a 1 minus cosine. If I multiply by a conjugate, I'd multiply by 1 plus cosine. So if I did that, my denominator becomes 1 minus cosine squared, which is sine squared. That sine squared really doesn't get me anywhere towards secants. So if you start thinking that route right away, you're like, I don't know if that's going to work. Plus, if you notice, your original on the left and what's on the right are just basically reciprocal functions of one another. Since they're not squared, there's no square terms at all. It probably meant that nothing got FOILed out, nothing got multiplied by itself. But maybe what happened was, can I rewrite cosine in terms of secant? Mm-hmm. So change your cosines to secants and see what happens. You get 1 plus 1 over secant, 1 minus 1 over secant. What I'm doing is I'm creating a complex fraction to get common denominators. Common denominator at the top is going to be a secant. Fraction on the left needs a secant. Fraction on the right doesn't. Look what happens in the bottom. What's going to happen when you flip it? Yep. So when you bring this one up, you flip, you get secant over secant minus 1, and you verify. We did 50 in class yesterday.
It's not an always. There's no always in these things. Yes, every problem is independent of each other. Every situation is different. There's no this always works. 51. Guys, come on. Cotangent plus tangent quantity squared. And we wanted to make it work out to being cosecant secant squared. So, a couple things you can do. I sat here and when I was thinking about this one originally, bless you, I would probably go ahead and FOIL it, see what happens. Yes, sir.
Wait, couldn't you just take the cosecants and secants and put them in terms of cotangent?
Go left to right.
Oh.
But yeah, if you did it that way, then you get what cosecant. You still have to worry about your how things are squared when you multiply it out. Foiling All right. So we get cotangent squared, 2 cotangent, tangent, tangent squared. You okay with that? What happens with cotangent times tangent? Crosses out, doesn't it? Okay. So you get cotangent squared plus 2 plus tangent squared. 2 is what plus what?
1 plus 1.
What's cotangent squared plus 1? Yes, huh? These are reciprocals to one another? What happens when both are reciprocals together? This becomes cosecant.
Why would you times?
Oh, sorry.
And then so how do you get the final answer? Times.
Common denominator. Rewrite 1 over cosine squared plus 1 over sine squared. So you get sine squared plus cosine squared over cosine. I have it backwards for the cosecant, I apologize, but that's how it would work itself through. Once you have pluses, that's kind of the trick here. When you have a plus with reciprocals, get the common denominator, and usually, especially if it's cosecant secant, your numerator is going to wind up being sine squared or cosine squared, so it's going to wind up being 1. And your denominator becomes multiplied, and that's how you flip it back up.
That's fine.
52, like I said, we have to go right to left. I apologize on that one. In my notes on the calendar from last year when they handed this one out, in the note field it said, go right to left, and that's what I wanted. I just seem to have forgotten in my haste and giving you guys problems. I promise everything else I give you goes left to right. If I do it this way, it's tangent, cotangent, cosine, plus sine. And we want it to be secant plus cosecant. Okay. In order to get this one to go, you gotta FOIL it. Okay? You gotta FOIL this one out, because otherwise it's really not gonna get you anywhere. So you get tangent cosine, tangent sine, cotangent cosine, and cotangent sine. It is. Not tangent cosine. You were 2/3 of the way to a cosecant. You stopped at the S. Now go and write everything in terms of sines and cosines. Write everything in terms of sines and cosines at this point. You have sine over cosine, bless you, times cosine. Sine over cosine times sine. Cosine over sine times cosine. And cosine over sine times sine. Okay. Some of these will be able to simplify the fractions, some of them you won't. That's okay. All right. So the first and last fractions go like that. The two in the middle, I'm just going to rewrite. I get sine over 1 plus sine squared over cosine plus cosine squared over sine plus cosine.
Cosine squared.
Yeah. So now I have to get a common denominator to add those fractions. The common denominator is going to be cosine sine. We okay with that?
Yes.
All right. It's just a mess. But it cleans up pretty quick. Okay. First fraction needs both sine and a cosine. So I'm going to get sine squared, cosine. Fraction in the middle has a cosine, it needs a sine. Or sorry, second fraction, so I have sine cubed. Next one needs another cosine. Last one needs them both. Yes, sir. What? Nope. Not a Pythagorean. Okay. All right. Okay. So,
Take out a sine.
okay. Oh, sorry. Cosine plus sine, excuse me. I forgot that there were 3 of them. I'm like, whoa, that's 3. And second grouping, I take out a Are those two things in the parentheses the same thing? Yes. So we're basically factoring higher order polynomials here. So I get cosine.
Yeah, that.
Wait, oh. It's big mess.
It is. That second term now is 1. Okay. All right, we see that now? Basically, this turned out to be factor by grouping. This is a factor by grouping problem with a higher degree polynomial. Remember that trick when you had 4 terms? We always said, hey, see if you can factor via grouping. Guess what we just did? Factor via grouping.
Oh, Mr. Murphy.
Yes, sir.
I still don't quite get how you got from that.
Where? Here?
Yeah.
Here? So are these two things in the parentheses the same? I wrote it down. What's left? Sine squared plus cosine.
Oh, it's okay.
It's the same idea as, x minus 3 and an x minus 3, and there's a 2x and a 4. So are those same things in the parentheses the same? We wrote it down, and we just factor the rest. It's factor via grouping with a lot more letters. Right. So now,
This was math, not English.
Here's my 1. Now we're not done yet. I think we had to wind up with a cosecant secant or something like that?
Yep.
Okay. You should be able to see where that comes from now. Notice the numerator has 2 parts. The denominator is all multiplied together. Split them. Common denominator. They have the common denominator to rewrite them. Cosine over cosine sine plus sine over cosine sine. Guess what happens? 1 over sine, 1 over cosine, which is cosecant, secant.
What did you call something?
I'm sorry, what one?
The sine was
What sine squared? What's cosine squared?
Okay.
Oh boy.
Why can't we just say yes?
Alright. Is it just like solve down into like a giant combination? Because everybody had asked that doesn't go to our school that did this stuff never had to like it's what we do in our curriculum for next year. So I guess I didn't leave next one. When you go to the next one there, you've got sine over 1 plus cosine, and you wind up with reciprocals. This is one where you probably want to try and shoot for a conjugate. Or, in this case, actually, if you see, we can try a conjugate, or we can try and see if a reciprocal function is going to work. Notice how you're starting in your, when I say standard trig functions, I'm talking about cosine, sine, tangent. Those are your standards. Your reciprocals are secant, cosecant, cotangent, and all that.
Shouldn't the sine be over 1 plus cosine?
Oh, thank you. I glanced down and I saw the minus symbol, the problem below it, even though the one below it is a sine, so whatever. All right. So a lot of times when what happens with these things, you just take a guess and try something. Okay. I sat there when I first saw this one. I'm thinking, okay, sine's reciprocal is cosecant. Cotangent, I can get cotangent by moving the cosines, by moving some stuff around, maybe. So what I tried to do right off the bat is I tried the trick that we did earlier by turning this into 1 over secant for the denominator. I made a complex fraction. Now, if I make this a complex fraction, I get 1 over cosecant over 1 plus 1 over secant. Are you okay with that? When we did this one earlier, we wound up with this bottom part being just secant plus 1 all over secant. Okay? So, from this part here, I take that lower denominator and bring it and flip it. And I just wanted to see what would happen. So if I do that, I get secant over, was it secant plus 1? All right? Well, I don't know. I mean, we multiply across, we wind up with secant over cosecant, secant plus cosecant. Okay? Again, it's like, all right, I don't know what that's going to get me, aside from a really fractions and stuff. So it's worth a shot to see where it might lead you. It might lead you into something. It might not. You never know until you try it. If I did that, if I went any further, this part down here is what? 1 over cosine sine plus 1 over sine. If I did that back in terms of just sines and cosines, I'd get cosine sine, and then 1 plus cosine here. Are you okay with that?
How do you get the numerator to the 1?
Which one? The 1 over cosecant? Which
Sure. I mean, how do you
here?
get to the secant? You know, like how did you know right?
Here?
Oh, there.
This?
Yeah.
Cosecant, secant, 1 over cosine sine. Simple.
Oh,
Okay. If I did that again with the secant then would have been 1 over cosine. So if I'm looking at this part here, if I flip it, I have 1 over cosine times cosine sine over 1 plus cosine.
You started back where you began.
Oh yeah, that sucks. Yes, sir.
So when you have 1 over cosine sine plus 1 over sine, you get 1 plus cosine minus.
Common denominator. Common denominator is cosine sine. This one has them both. This one needs a cosine. So here, I want up what we call the good old-fashioned infinite loop. I want up where I began, and I said, oh, shucks. Let's try something different.
I don't think you use shucks.
Fiddlesticks.
Or that.
Wait, this is just got limited.
Now, again, we need to make this, what was it, cosecant minus cotangent? Yes. All right. So, plan A didn't work out so well, so I'm going to try another idea. The other idea here is sometimes you try out a conjugate. So if I try a conjugate,
One plus cosine.
I did that last time too. Sorry. Sorry. So I do the conjugate in this case. If I do the conjugate, my denominator becomes 1 minus cosine squared. You okay with that? What's 1 minus cosine squared?
Those two things will apply together.
Correct. But in other words, it's called sine squared. Okay? My numerator, excuse me, my numerator becomes sine times quantity 1 minus cosine.
Sine should fly.
Sines fly out, right? One sine goes away, then all of a sudden I have 1 minus cosine over sine. Oh, look at that. 2 parts in the numerator, 1 part in the denominator. There's your common denominator, 2 fractions. Huh. Cosecant minus cotangent. Okay.
So,
Remember,
so trying to, or do you want to try to do?
I tried just going into common denominators because I saw that I was ending up in reciprocal functions, so I thought I would give it a shot. It didn't get me anywhere, so I tried to do something different. That's the idea. You could go. I chose poorly. You know, I did my choose your own adventure book and I died. So, want that? So what happens is sometimes that happens, and that's okay. You just recover and you try again. Okay? This is not easy. This has never been easy. This takes a lot of practice to get through it. It takes, I've done it forever, that's why. But the idea is I'm trying to give you guys as many examples and ideas of things to try. Okay? That's the idea behind this, is to give you situations to remember, okay, that didn't work, let me try something different. Okay? It's okay to have what we call productive struggle. It's fun. I believe, what is it? 54 is kind of the same idea. And I think 55 is 2, so. Let's just jump right to 55, see what happens with the conjugates. Oh, I'm sorry, go to 56, because I don't know how much time we got left. Yeah, 256.
56 more than 90.
Okay, I got it. So, when I'm looking at this one, you start with secants and tangents, you end with secants and tangents. You cross multiply, and it equals 1! No. So, now, obviously I could try and do sines and cosines, get common denominators, see what would happen. But I don't know if it's going to work or not. One of the things I would try, though, is try and do a conjugate with the numerator. Is there any rule that says you can't do that? No. No. It's kind of like how you would unrationalize something. Okay? Yes, sir.
There's only one rule in math. Math, don't kill companies.
There you go. Just watch this. When you multiply by a conjugate, I'm still multiplied by some factor of 1, aren't I?
Yes.
What's secant minus 1 times secant plus 1? Which is what?
Oh my God.
Oh, they still apply the same. So you can multiply by, yeah.
You know cosine squared plus sine squared?
1.
Okay, then you can rewrite everything else.
Yeah, but how'd you get the secant plus
It's a conjugate. It's a factor of 1. It's a factor of 1.
Wait, so
They simplify out your tangent squared. You're done. You're verified.
oh, it is.
There you go.
Yeah, but wait. Oh, I'm thinking.
Guys. We do. I believe 54. If I'm not mistaken, on 54, what I would do, I got 1 over cosine minus sine. Guys, enough. We'll leave it like that for right now. I saw cosine, secant minus tangent. I knew right away if I wrote those as fractions, they would have a common denominator. So I wrote it down right off the bat. Bring it up and flip it.
What do you want on this sign?
From the problems. There's your secant. And I'm pretty sure 55, if I'm not mistaken, I did I did conjugate on that one also. When you go this route with the on 55, if I go right off the bat and try and do the conjugate off that, you're going to get 1 minus sine squared, which is cosine squared. That drops. 2 parts in the numerator, 1 part in the denominator, split into 2 fractions, and you're done. Oh no, it's not the numerator. Sorry, that's the denominator. So they did something different. They did an extra step here. So this one went. Oops, sorry. This one went 1 over 1 plus sine. 1 over cosine. Which is secant tangent. What do they do about conjugate then? Oh god, that's a so
1 minus sine.
yeah. Yep. Because when you FOIL this out, you'll get secant squared minus tangent squared. What's secant squared minus tangent squared? 1. That's how it goes. What's up? It should work too. Yeah. If you get through there's a lot of different ways of going through those things. I saw how it flipped it. I saw how it went from the secant tangent. I'm like, okay, then it had to be common denominator with some sort of a flip. And then when I got to here, the secant plus tangent all over 1, and I knew that it had to be a minus. I knew that, if I multiply this by the conjugate again, I'm going to wind up with the numerator being secant squared minus tangent squared over secant minus tangent. And secant squared minus tangent squared comes from the identity. Secant squared minus tangent squared is 1. That's where I got that from. But yeah, there's going to be more than one way to go about it.
What's the
I just proved it.
It's just secret.
No, we had to verify. Remember, it's a verified problem. Okay.
Oh, it is. Okay.
So I'm getting it to look like I didn't write it down because it had to equal. Okay. What I have done is I have another set of problems here on this sheet, or these sheets, I should say. There's approximately 106 different ones of these. What I have posted online are the solutions to the first 2 pages. The rest of them, I'm pretty sure I have answers for all of it lying around somewhere. I gotta dig them up. If I do in fact find them, I will post them. If not, at least you have solutions for the first 16. Like you're gonna do 106 of them. Chances are there's a few of them that are thrown in there that have square roots. Do not worry about anything that says square root on that. That's some of the identities that you'll do next year.
The whole thing is that you always say in the more problems, so if you give me problems and I don't try them, you can use that again.
It is what I printed off the internet. So, ladies and gentlemen, again, the first 2 pages, first front back, I should say, I have posted already the solutions to those. I'm pretty sure somewhere over the course of the past 15 years, I still have a yellow legal pad with the answers to the rest of them. I'm going to dig that up, see if I can find it, and then post it. If not, at least you got the first couple pages. Sir? You said that. Okay. Yep. There's be about 4, it's either 4 or 5, and I haven't quite decided how many I want to do. Probably 5. Nope. You get nothing. This is on you. Okay. What? I just said 4 or 5. So like it. Okay. Yes, sir. I did. Nope.